Greeting to everyone. The title of the paper is Effectiveness of Partial Wrapping of Stainless Steel Wire Mesh on the Compressive Behavior of Concrete Cylinder. Wrapping of concrete cylinder with material having higher tensile strength improve the compressive strength as compared to unconfined concrete cylinder. Various type of fiber reinforced polymer composite commonly used for the wrapping on the concrete element are such as glass fiber reinforced polymer, carbon fiber reinforced polymer, and aramide fiber reinforced polymer. Stainless steel wire mesh has recently been explored as an alternative to FRP for strengthening concrete structural element. SSWM is having bidirectional plane wave of steel wire manufactured from SS304. SSWM is locally available cost-effective material. SS40x32 is used in the present study. The physical property of SSWM are given in the table. The mechanical property of SSWM such as modulus of elasticity, the tensile strength are obtained through the coupon test. For the simplicity, the stress-strain curve of SSWM is characterized by the two straight line. This bilinear straight line curve is used for developing an analytical model for SSWM wrap concrete cylinder. Total 18 concrete cylinder specimen of M25 grade concrete with 150 mm diameter and the 300 mm height are tested under the axial compression load. Different extent of the SSWM confinement is considered. It is include full wrapping and the wrapping of SSWM strip at the end with a different gap. Wrapping configuration and the experimental test setup are shown in the figure. The Tikadu 30 LP is used to attach the SSWM on the concrete surface. From the experimental result, it is found that the gap between the SSWM strip is increased. There is a noticeable reduction in the axial and the circumference stresses and strain in the wrap region. The strain softening response are observed when the gap between the strip is lower than the specimen diameter, signifying the sufficient confinement and the ductile behavior. When the gap between the SSWM strip is beyond the specimen diameter, the effectiveness of confinement becomes negligible. Analytical studies to estimate the compressive strength of FRP confined concrete are available in the literature. However, there is a lack of analytical model to quantify the role of SSWM in confinement of the concrete cylinder. The SSWM wrapping exerted a passive confinement action on the concrete cylinder due to the lateral expansion of the concrete under the axial load. Uniform radial pressure created against the lateral expansion of SSWM confined concrete developed the tensile hoof stress, which lead to the increase in axial stress and the corresponding increase in the lateral strain. Analytical model is developed in the present study to predict the compressive strength of the SSWM confined concrete based on the model proposed by the Richards and al. Various factors influencing the confinement of the concrete by SSWM are presented in the present study. The conclusion of the study. The compressive strength and the strain capacity of the specimen wrapped with the SSWM exhibit improvement as compared to unconfined concrete cylinder. The rupture of SSWM observed in the confined concrete when the gap between the SSWM strip is less than the diameter of the cylinder indicate the effectiveness of the confinement. Based on the statistical analysis, it is found that the proposed analytical model accurately predicts the peak and compressive strength of partially SSWM confined concrete. The author would like to thank the DST as well as Nirma University and the IIT Hyderabad for their support in the present work. Thank you.